mostly floating wind. But I'm actually interning this summer with the floating wind technology company.
Mhm.
Very cool.
So, Kevin, there was a, a Zoom meeting announcement. What are you studying? What's your PhD on, or what's your area of interest in school?
Yeah, my mostly it's floating wind,
Floating. Okay.
specifically substructure design.
Yeah.
Um, but I've done a little bit of distributed wind as
Okay.
well.
Yeah. Yeah. That's a heck of a technical challenge trying to make an affordable floating wind turbine platform.
Yeah.
Kind of glad I'm out of that one.
Oh, no, they'd welcome you back, I'm sure, if you wanted to come help.
Yeah.
Awesome. Well, thank you guys for introducing yourselves and my goodness. Hopefully we'll have some others joining us as we get further in, but welcome to the second of our summer webinar series for the College Student Network. You're still seeing my screen, right?
Yes.
Just a couple of updates and event announcements here on the Repairing Schools side of things. The first is that you guys were able to join us at IPF, the offshore conference in Virginia earlier this year. Our next conference that we are accepting applications for is the RE Plus conference in Las Vegas, the beginning of September. So that QR code will get you to our application, and we are going to be accepting up to 12 students to come with us to Las Vegas. Again, that is hotel accommodation, free registration, and then we do orientation, industry meet and greets, just kind of like we did with you all. There is a career fair that's put on by Rise and Grid Alternatives. I think that's it. And then we usually try to find mentors to walk through the show floor with you for the first time, because it's if you thought the offshore conference was interesting and exciting, this is probably about 20 times the size of that. They're expecting 50,000 people, so it's going to be crazy. So it is always helpful to have a buddy who knows what they're doing when you walk on that exhibit floor for the first time. So happy to provide those resources for you all. Um, so if you want to apply, that is the best way to do that. You can also just go to the website under our conference experiences page and also find the application. The other thing to remind you guys about is that we do host our annual Renewable Energy Education Awards in concert with Kidwind, and our public voting is closed, and the ceremony will be virtual on Zoom tomorrow evening at 7 p.m. And we will be announcing our outstanding educators, our industry champion, our student excellence awards, our special recognition award, and then recognizing our repowered schools. So you may want to be present for that. Hint, hint, Jake, JMU was nominated for a Repowered Schools Award. So JMU may be recognized. So if you want to be there. And
Yeah.
then some of our your fellow students are being recognized in that student excellence category too. So something that you're more than welcome to join us for live tomorrow evening, but it'll also be recorded and put on our YouTube channel for future reference if you'd like to see that later. And that's really it from our side of things in terms of what's going on right now. But just remember that these conversations that we have during our student summer webinar series are also recorded and put in our YouTube channel. So I highly recommend that you check out our YouTube channel. It's got lots of great resources for past webinar series, past awards programs, past, lots of things. So feel free to check that out at your convenience. And with that, I will turn it over to Mike here to kind of kick off our conversation for the day. And again, happy to keep it as formal or informal as you like, Mike. And I will
Okay.
stop sharing my screen, and you are welcome to share any slides you have.
All right. Very good. Let me get that going.
And while Mike's bringing up his slides, just know we do all these conference experiences, and it really started with us bringing students to the Distributed Wind Energy Conference, which happens annually in February in the DC area. So very accessible for you all if you're ever interested in joining us. We offer that that opportunity And Mike has always been such a gracious host to us. So thank you for being here.
You're very welcome, Remy. And Kevin and Jacobs, nice to meet you. Let me give, before I launch into a presentation on from DWEA, my origin story for getting into the wind industry started when I was a student at the University of Oklahoma studying mechanical engineering. My father was on the faculty and had a background in aircraft design, and had led him into studies on wind energy feasibility in Oklahoma, where it gets windy occasionally. And I came up through school, worked on an electric car project as a gopher, worked on a wind turbine project as a gopher, and then led a wind turbine project in my junior and senior year that won a national design award. And I just caught the bug. Working in wind power is a extremely challenging field of engineering that hits a lot of disciplines in order to get something to work in this capricious energy source. And I was fascinated by it then, fascinated by it now, and have enjoyed the last 50 years in the industry that I've been involved in. Bergey Wind Power is the leading manufacturer of small wind turbines in the U.S. We're in our 48th year, and we're doing well these days. I've been president of the Distributed Wind Energy Association since its forming, except for 2 years when someone else took the helm. We're in our 15th year. Prior to that, I was served on the board of the American Wind Energy Association for 27 years and was president of that association twice. But distributed wind is very much different from wind farm industry, and the main difference is that our turbines, for the most part, it might be one or more turbines, but generally not very many, and they're behind the meter. So they're serving some sort of a building. It could be a home, could be a farm, some sort of a business, or a public facility, but it's meant to offset the consumption of utility power. If these systems don't have storage, they shut down during power outages, and as they produce energy, electricity instantaneously, it's either used in the facility or it's sold immediately to the utility company. And so that makes the terms under which excess power is sold important to the overall system economics. You can add storage to these systems like you can with solar and create something that has the ability to provide backup power. That's not nearly as common with distributed wind as it is with solar, but that's certainly on the horizon. Microgrids are an up and coming aspect of our industry. The benefits of distributed wind are that it can be a least cost technology. Where there's a good wind resource, as I'm sure you're well aware, the power in the wind goes with the cube and the energy goes with the square of the average wind speed. So solar is linear with its resource. So the difference between the worst sites for wind and the best sites for wind is much greater than with solar. And so we can, on very good sites, do quite well even against low-cost solar. It leverages American technology and manufacturing strengths. We've had an industry active in small and medium wind for the last 40 years, and there's a lot of advanced technology and manufacturing in our industry. It can complement solar, and I'll talk about that more in a minute. And if you use both wind and solar, you can get away with less storage and backup because you have a more reliable source of clean energy daily and year round. And very important because the agricultural markets are significant for distributed wind is that we have a much smaller footprint compared to solar, and farmers are quite sensitive on taking up valuable cropland, and so we actually have a real advantage over solar in terms of a space we require. With the new technology, the grid forming inverter technology with storage, we can strengthen the grid. If you're in an area that's winter peaking for heat, for example, our wind resource aligns with the demand, and there are places in California where we're even peaking on summer. The wind can ramp in terms of volume production faster than some other clean energy technologies. But we haven't, because of the competitiveness of Chinese solar modules, we haven't been able to fully exploit that capability. And because we're highly visible, we stick way up in the air. And if you look at advertising for cars and all sorts of consumer goods, wind power is often placed in an ad for its iconology for stewardship, environmental stewardship. So we have companies that put wind systems in so that they can brand themselves as green, or helps do that. One of the important things to keep in mind is that even though distributed wind is much more expensive to install, multiples of 2 or 3 times more expensive to install than large-scale turbines and wind farms, we're selling into the retail market, not the wholesale market. So the value of the electricity that's produced is much higher in a behind-the-meter scheme. So don't be fooled when somebody says, a small and medium wind doesn't make any sense because it's so much more expensive than large wind. Those opponents completely miss the point that the value of the electricity is much higher for a distributed wind system. I mentioned the seasonal complementariness with solar. It's also daily, the diurnal. Quite often, solar, of course, peaks in the day and has midday and has no output at night, but the wind often is lowest midday and does operate through the night in many, if not most places. And then on a seasonal basis, solar is summer peaking, of course, and then wind is winter and spring peaking. So if you combine the two sources, you have more reliable power, clean power. We are, in our industry, a jobs machine. A lot of solar is highly automated, partly because of the job functions involved and the lower production rate. We're much more labor intensive. So per kilowatt hour of production, we have our costs are much more made up of labor content. So we're better from a jobs perspective. This gives you a sense of scale. You guys already know all this, but this is good pictorial. A typical rural distributed wind turbine is 15 kilowatts, 31-foot rotor diameter, 100-foot tower, and then you can see how much smaller that is compared to a common utility scale land-based wind systems. We classify wind turbines in the distributed wind space in small, medium, and large. We break small it's up to 100 kW, mid-size is from 101 up to 1,000 kW, and these are the companies that are involved in those markets. Manufacturers. So we're the leading supplier. EOCycle out of Canada is a major supplier, and Northern Power makes 100 kW and is they built in Italy, but they're coming back into the U.S. and there's a number of other manufacturers here. So we have some new entrants. The Department of Energy has been supportive. They have programs like the Competitiveness Improvement Program that provides cost-shared R&D support, which has really helped to advance the technology. And that funding's been spread over quite a few companies, including my own company. Here's a couple examples of distributed wind projects. Here's a 15 kW turbine in Nebraska at a farm installed in 2022. It produces about 35,000 kilowatt hours per year, and it's about a 3-year payback with the incentives that have been provided, both tax credits and USDA grants. Here's a project, a little older, what's 9 years now, in eastern Colorado at a dairy farm, two 100 kW turbines, and that produce about 60% of their energy, and it's connected to a rural electric cooperative. And then one of my favorites is the Anheuser-Busch Brewery. These are large turbines, large General Electric turbines. They've installed two now, and they provide about 30% of the energy demand. Or my favorite metric is it's equal to 33,000 cases of beer per day. I like that. They were installed under a power purchase agreement by Foundation Wind Power, a California company that's a member of DWEA.
But who really needs 33,000 cases of Bud Light, honestly?
Well, I happen to drink Bud Light, but it would take me a while.
Well, okay.
It would take me a while. This is a map that just shows, it's a wind map of the U.S., of course, but it shows where most of the distributed wind development is being done. It's in the Midwest and up in the Northeast. Midwest because of the high wind resources, and Northeast because of the high electric rates. But NREL has done some studies that show that distributed wind is feasible at about 50 million sites around the country, and has a economic feasibility potential in 2022 when they did the study of 1,400 gigawatts, and an economic feasibility in 2035 with cost reductions of about 6,000 gigawatts, which puts it actually as a larger potential than offshore wind. And we'd like to think that they're complementary because offshore wind serves larger coastal communities, but distributed wind serves smaller interior, transitional, and more disadvantaged communities. And both have large technical and economic potential over the next 25 years. But in order to realize that, we're going to have to reduce the cost of distributed wind considerably. And DWEA has done some projections. And so for different size turbines, this is the 2016 LCOE. This is from a 2015 2016 DWEA vision report, which is available on our website in more detail. But you can see we're projecting substantial reductions in the levelized cost of energy for different size turbines. And so this table shows the sizes, the recommended heights, the typical users, the 2016 LCOE, and the projected 2035 LCOE. When you start getting down into the 6.5, 5 to 7 cent per kilowatt hour before any subsidies, you're well under the national average of electricity costs, which is right around 13 cents now. So, we think, in spite of what may happen in Congress, we think we've got a good potential over the long term. And here's an example, of an advanced distributed wind technology, the way we've been able to use some of the government funding. This is a 2010 technology, this is actually one these are Bergey Wind Power products. So we were at about 21 cents per kilowatt hour. And with the new technology, new airfoils, better alternator, better power electronics, we more than double, increase the efficiency by 30% and lower the LCOE by more than 50% to 9 cents per kilowatt hour.
And just to give Jake a little bit of context, that's the turbine that we have on campus, the little yellow one.
Yeah.
Okay. We need an upgrade. We've talked about that for the summer.
That's a significant market for us because the 15 kW can go on the same tower as the older 10 kW with more than double the energy production. So lots of repowering on that. Particularly since I just got Ramey, you'll know Ryan Stork. He just sent some pictures. He was doing some work on a Bergey 10 kW turbine installed in New Hampshire in 1985. And so it's been running without any repairs since that time. Just recently developed a short circuit in the alternator, and so they're fixing the alternator. But that's a
It's amazing.
40-year-old turbine, and he sent pictures, and it looks new.
That's crazy.
Yeah, pretty neat. So the distributed wind industry benefits from robust federal support, which is currently under attack, and has the industry as well as our colleagues in the solar and storage industry quite worried and doing a lot of lobbying in Washington. But as it exists now, there's a 30% credit for residential and business purchases. And then if it's a business purchase, there's some bonuses for domestic content, for being in an energy community, and some others. The credits can be transferred, and if you're a nonprofit, you can get a rebate from the Treasury. This has really helped to grow the industry, and encouraged companies like Bergey Power and a lot of solar companies to invest in additional manufacturing capabilities. And we may get the rug pulled out from under us, which is not much fun, but we're hopeful that the Senate will be more rational, and that ultimately there'll be a phase down of these credits rather than just ending them after 60 days, which is what the House has proposed. There are also robust grants from the U.S. Department of Agriculture under the REAP program. The funding for that's continued, although the rules are a little uncertain at this point, and it's likely to be a 25% grant, not a 50% grant. So that's the situation with the distributed wind energy industry. We're on pins and needles right now, but hopeful that that Congress will not completely pull the rug out from under us, and in which case we can continue to develop the technology, continue to reduce costs, and continue to expand the market.
Thank you so much, Mike, for that overview. I want to open it up to Jake and Kevin for questions, but just a quick comment before I do that is this is just such a timely presentation. I was actually just on the distributed wind workforce calls, and we were talking about how important it is that more college students and even high school students know about distributed wind and about the career opportunities that it provides, because they're very different from what the traditional wind industry, land-based and offshore, offers in terms of career opportunities. I call it like the jack of all trades. Like I heard, we mentioned that, but it's definitely a very different environment. I think it's kind of an all-in, anyway, I just think it's really cool. And I'm so glad you're here, Mike, but I'm opening it up.
Well, even a 45-year-old company like Bergey Power operates like a startup. So, it's we don't have a ping pong table.
No, not made a ping pong table made out of solar panels, because I see those all the time.
Yeah. We'll have our conference in February, late February again, in Arlington, Virginia. We have a day and a half business conference for the association, Monday through Tuesday at noon. And then the Department of Energy and the national labs typically have a industry feedback session on Tuesday afternoon. And then on Wednesday, we go up on Capitol Hill, and typically we have 30 to 50 people and anywhere from 40 to 60 meetings, in-person meetings up on Capitol Hill. That's a very good way for us to communicate our vision and of the industry, and to try to shape the policies that are so important to the development of our industry. And we've had the pleasure of having involvement of a number of students from REpowering schools, and Remy, we're going to do it again in 2026.
as long as my board lets me. But yes, so with that, guys, if you did come and participate, the cool part is that we do a poster session during one of their networking receptions, which is really a great time to get to know these guys. And we also offer a field trip that we'll have to figure out how we're going to play with that, because this past year, our students actually participated in the lobbying, which was a really great experience for those students to kind of get a feel for what it's like to go up on the hill and actually, talk to really needed decision makers about this important topic. So we definitely want to make that opportunity available again next year, if that's okay with the folks at DWEA, but also want to make sure we get you out to a local business to kind of, interact. Last year we went to Sol Systems, which is a solar installer. You go down into their headquarters in DC, and they actually invited us to have a poster session for all of their employees, which was really cool.
Cool.
And the students got to present their projects to the entire staff, which was really an amazing opportunity. So all the things we want to do it. So yeah. Do you guys have any questions for Mike about any of what we've talked about?
Not too many, but you mentioned that like microgrids are in the up and up, and
Yeah.
I think I've got a lot of interest there just with like the combination of solar, wind, and storage. Do you have any more to talk about on that, or like advice to somewhere I could look more into?
Well, there's pretty good competition between Tesla Energy and a number of Chinese imports for smaller scale solar storage systems. States like California have put in robust subsidies for that, particularly in the wake of the fires and power outages that they had. And for wind systems, because there's this huge industry for solar-based storage systems, we're all working on interfaces that will allow us to use some of those mass production products, but bridge the difference between the way in which you charge a battery with a solar system and charge a battery with a wind system. And a lot of it has to do with the voltage operating range, the fact that you can't use a maximum power point tracking scheme on a wind system, which are typically baked into these solar storage products. And I know we've been doing that here, and I expect my colleagues, competitors have been doing the same. I think companies like EOCycle and Northern Power already are offering products, although I don't think they are integrated with the solar systems yet.
Doesn't
But we see a
Rise do a
big
lot with the
potential in that.
air product and doing hybrid systems?
They do, yeah. That's a
Yeah.
good point. Yeah, thank you. Yeah, Rise is a roll-up of several older wind companies, Gaia in the UK and Energia in Spain. Rise bought those product lines and is working with Blandon microturbines, which is a high speed, very very high a turbo generator, small scale for telecom applications primarily, but they work together and they do a number of hybrid wind, solar, and backup generation systems around the world. So yeah, they're a good resource.
And I
Thank you.
don't know if they offer them, Jake, but when Primus Wind Energy, before they were acquired by Rise, they used to have like webinars that you could go to about how to take a micro turbine and some solar panels and connect them to some batteries. So they did a little bit of like a hybrid teaching on their website. So you might, I can look it up and see if I can send that to you if I find them. But yeah, that was
Yeah.
The gentleman who did that has left the company, so I'm not sure if someone picked that up or not.
Right. I'll just make a general comment on that. If you're off grid and you know the cost of backup generation is high because you're getting that from a diesel generator or micro turbine, then wind and solar together makes a lot of sense because it saves uh, operating costs. If your backup power is the utility grid, however, combining both wind and solar is not as attractive because the value of reducing the need for backup power is not as valuable. And so people typically are going to pick either as a just have one primary source. Right now, it's mostly solar, or wind, but it's not likely on a grid connected system to be both.
Good questions.
Yeah.
I had a question, and thank you for the talk. I really enjoyed it. There's one thing I know, more like the research side, it seems like to drive LCOE, you go a lot more with a bigger rotor. Um, and that's what I've generally seen as the main way of driving LCOE down. It sounds like, you know, the distributed scale can't really do that too much. It's more optimizing the performance of individual components. Um, so because I was just kind of curious, is
Yeah.
one just like, is there a limit to how much you can improve that performance? Or is there like eventually the trade-off just doesn't make sense?
Yeah. Well, actually, the recipe for lower LCOE is pretty similar for smaller scale turbines as it is for big scale. And, you know, essentially that means, as you say, bigger rotors. And in order to do that, you have to figure out how to make uh, something. Well, in our case, since we don't have a pitch blade pitch, um, we have to figure out the aerodynamics of stall regulation that allow, and particularly dynamic stall, so that we can put bigger rotors on the same, uh, bigger and bigger rotors on the same structure, the same nacelle, the same tower, the same foundation, increasing energy capture and then driving down LCOE because your CapEx doesn't increase as much as your energy capture does. Um, and that's what the General Electrics and Vestas did. They figured out the aerodynamics that allow them to put bigger and bigger rotors with the same or small increases in thrust load, so that they can not have a proportionally bigger structure. So we do the same thing. We did the same thing. In fact, my company, because we have a particular strength in airfoil design, developed proprietary airfoils that allow us to do what we did with the 10 to the 15, where we've got a 88% bigger rotor, but we've got the same thrust loads. So it's the same thing, but then trying once you can make those big leaps, but then you have to wean out some additional smaller inefficient efficiencies with better alternators, better power electronics, um, uh, more efficient and inexpensive ways to put in foundations, cheaper ways to make towers. There's a lot of component optimization, value engineering, but the big gains is from the better economics or better aerodynamics to put it bigger rotors on the same nacelle.
Like, yeah, that makes sense.
Yeah.
I don't know if there's time for one more question. Um, I was just kind of curious too of I mean, larger turbines onshore and even offshore, there's a lot of, I guess, public opposition, either visual, noise, environmental concerns,
Mhm.
and permits. As I'm just kind of curious, I mean, I think you said 48 years you've been in the distributed wind industry. How has it changed over that 40 years?
Well, so um, we've received a lot of collateral damage from the um, NIMBYs for large wind. So, some of the blade throw, ice throw, noise, ultrasound, um, the stray voltage concerns that get at birds get thrown up for large wind are assumed to apply equally to small wind. And so back when we delivered our first turbine in 1980, there were no concerns at all, but the uh, more opposition sort of developed over time with more and more large wind development. Um, but where the market is now in rural areas, it's not much of a problem. The people are used to things being making some noise. They're not as sensitive to aesthetics considerations. Um, they've been using wind power on farms for 125 years, so um, they're sort of they feel more comfortable with it. So, but that we're not seeing too much of that these days because we're primarily in agricultural settings. If the market picks back up for residential for small wind, I fully expect we'll, we'll face all of those issues much more prominently. Um, and in fact, we're starting to sort of um, spin up on getting NREL and other government labs to sort of help us with the permitting issues that we have faced in the past and face in the future.
Thank
Great
you for,
questions.
Yeah.
Yeah. Thank you. And just to follow up on that, you bring up an interesting point. Right now in the kind of utility scale industry, one of the biggest problems that we're seeing is siting and permitting, mainly from public acceptance and, kind of community misinformation and things like that. Um, so you don't really see as much of that until you kind of go back into that residential space. Is that what you're saying?
Yeah, yeah. In the rural applications, it's not as big a concern. And you know, um, as you move towards, well, Bergen Power has been active in the residential market in years past. Right now, it's mostly agricultural, but um, uh, yeah, I mean, you start to see the NIMBYs. So you go from an over-the-counter $25 building permit with no requirements in a rural county in the Midwest to a elaborate um, permitting procedure. Los Angeles County it takes 18 months, costs $5,000 or $6,000. There's a public hearing requirement. There's notifications of all neighbors within I think it's a 1 mile radius. Things that seem quite overblown and are, um, but it's a mixture. Some are um, that's a worst case.
Yeah.
We tried to actually, I have a new worst case. We worked with L'Oreal, the huge cosmetics company, to put a 15 kW turbine at their 300,000 square foot warehouse, which is right next to a Amazon fulfillment center in Dallas, Texas, in a rural part of Dallas County. we spent 4 years, $26,000, including hiring a fixer to try to get things through, and we were ultimately denied a permit that we had to, a conditional a variance that we needed because the light industrial zoning for the L'Oreal warehouse had a 70-foot height restriction, and we asked for 97 feet. So that 17-foot killed the whole project. But that's because the planning board didn't like it, and the uh, 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 appeals committee, I can't think of their name right now, was headed by a woman who's active in the oil and gas industry.
My goodness.
So, you know, yeah, that was sort of disappointing.
Oh, that is a bummer. That's a lot of money to sink into a project that never happened.
Yeah, we've never done anything like that in the past.
That's crazy.
Yeah.
Well, wonderful. Well, I appreciate your time, Mike and
Mhm.
Jake and Kevin. Thank you for being here. We have 15 minutes left, but I mean, I don't want to take up time if y'all don't have anything. Usually at this point, we would kind of dig a little bit deeper into talking to the students on the call. So, I mean, Jake and Kevin, if either of you want to talk a little bit more about like what you're doing and over the summer related to your work. I mean, we can chat about that, but otherwise, that's pretty much the end of our call agenda.
Well, thanks for the talk, Mike.
Yeah, no, my pleasure. Good meeting you guys, and good luck with your studies and your careers. And maybe I'll get to see you in Washington, D.C. in February.
Yes, sir. Thank you.
Yeah. And
All
just
right.
know that we do have another call next week, same time, same place, and we'll be hearing from Rob Pruce, and he is a consultant. He works in also in the small wind space, but more in the I don't know, Mike. You probably know him better than I do. Maybe you could give a
Yeah,
better.
let me give you a little promotional. Yeah, Robert's a hell of a guy with a lot of experience. He was an importer of South African small wind turbines, then designed and built his own, and was quite successful at that until he went bankrupt in what is a tough business. Um, well, I think and he sold that. Anyway, he got out of the business, sold that to another company that uh, e- expanded the product, did quite well for a while, and then got out of the business. But he's done a lot of consulting work, and he worked at the National Renewable Energy Laboratory as one of their principal technical managers for he'll tell you, but I'm going to guess around 15 years. And so he has a lot of insight into, you know, different manufacturers, technology development programs, and he's just a wealth of experience in that area. So, Remy, send me an invite. I want to sit in.
Sounds great. I will add you to next week's call as well. And
Yeah,
Kevin and Jake, I hope you have a great rest of your week and look forward to seeing you next week if you're available.
yeah, yeah. All right. Bye bye.
Thank you guys.
Thank you.